Welcome to this explainer. Look, we are right in the middle of a massive paradigm shift in how organizations build and deploy technology. I mean, for decades, enterprise software was deterministic, right? You wrote the code, you tested it, and if it passed, you were golden. But generative AI doesn't work that way. AI is probabilistic. It is wonderfully unpredictable, which means we need a massive shift in our thinking. We're talking about moving away from static, one-time testing and moving toward continuous, probabilistic AI evaluation. So today, we're going to dive deep into exactly how enterprises should be benchmarking AI models using the DrPinnacle framework.
So let me ask you something. Are public AI benchmarks actually failing your enterprise? Honestly, there's this really dangerous false sense of security that comes from relying purely on standard public benchmarks to tell you if a model is ready for prime time. We're dealing with a classic myth versus reality situation here. The myth? Well, that's the idea that if a model crushes a public leaderboard, it's perfectly safe for your company. The reality, though, is that without continuous business-specific evaluation, you might literally be flying blind. Here is the roadmap for this explainer. First, we'll hit the static benchmark illusion. Then, defining trustworthy enterprise AI and scientific validation. After that, we'll jump into red teaming and AI safety, securing the AI system, and wrap it all up with the continuous mandate.
All right, kicking things off with Section 1, the static benchmark illusion.
You know, a static test really only tells you how a model performed yesterday. It tells you absolutely nothing about tomorrow. Standard public benchmarks, things like MMLU, GSM-8K, and HelloSwag, they're great for general comparisons, sure, but they completely lack your specific business context. Plus, there's this massive risk of data contamination. It's kind of like giving a student the test paper the night before the actual exam. Of course they're going to pass. Custom benchmarks that evaluate your enterprise-specific tasks with real-world context, that is the absolute only way to verify if a model actually works for your specific use case.
Because without that custom validation, we open the door to massive probabilistic AI risks. We are talking about harmful or heavily biased outputs. We're talking about hallucinations where the AI confidently just lies to your users. We face severe data privacy leakage, vulnerability to jailbreaks, and, honestly, extreme latency issues that can completely ruin the customer experience. These are unique, absolutely critical risks that demand a fundamentally new approach to enterprise safety.
Moving right along to Section 2. Defining trustworthy enterprise AI.
To actually combat those risks, we need a holistic approach, which brings us to the DrPinnacle end-to-end enterprise AI architecture framework. The core formula driving this whole framework is so important. It states that trustworthy AI equals accurate, plus reliable, plus safe, plus secure, plus aligned with business values. I mean, you can't just have accuracy without safety, and you certainly can't have safety without security, right? The DrPinnacle framework mandates that we evaluate all of these pillars simultaneously. That's how you build trust, reduce risk, and actually drive real business impact.
Which leads us straight into Section 3, scientific validation and benchmarking. Listen, evaluating AI is not a vibe check. It's not about playing around with a chatbot for 5 minutes and saying, yeah, looks good to me. We need hard, quantifiable metrics like expected calibration error, or ECE. ECE essentially measures the gap between a model's actual accuracy and its confidence level. Think about it. If a model's only 50% accurate, but it's 99% confident in its answer, yeah, you've got a massive problem on your hands. ECE quantifies probabilistic trust, making sure the AI isn't overly confident when it's actually completely wrong. And with ECE, a lower score is always better.
Because true validation relies on rigorous math. Take a look at this expected risk formula, pulled straight from the scientific foundations of the DrPinnacle framework. It calculates the expected loss across a distribution of data. We aren't just guessing here. We are literally calculating generalization risk to mathematically prove that the model performs consistently on unseen data. It is a highly scientific process that proves an AI model is actually ready for production.
Let's dive into Section 4, red teaming and AI safety.
So validation proves the model works when things go right, but AI safety, that ensures it doesn't fail catastrophically when someone is actively trying to break it. Let's break down these core dimensions. First up, harmlessness. The goal here is zero toxic, violent, or illegal content, and we measure that with a toxicity or harm rate. Second, truthfulness, prioritizing factual accuracy and shutting down those hallucinations. And third, robustness, making the model resistant to jailbreaks.
Think of a jailbreak like a hacker tricking the AI into writing malicious code just by asking it to say, write a poem about malware. We calculate this resilience by taking the successful jailbreaks and dividing them by the total attempts to get our jailbreak success rate. And just like before, lower is always better.
Next up, Section 5, Securing the AI System.
The DrPinnacle framework outlines a few absolutely critical security vectors you have to lock down. You need data security to protect personally identifiable information. You need model security to protect your valuable IP and model weights from extraction. Prompt security is huge for defending against injection attacks and data exfiltration. And you absolutely cannot sleep on infrastructure and supply chain security. I mean, if the data set or the dependencies you downloaded from some open source hub are compromised, the whole shebang is compromised.
To secure data effectively, the framework points us to formal methods like differential privacy. And this isn't just a nice-to-have best practice. It's a formal mathematical guarantee. It ensures that the inclusion or exclusion of a single data point doesn't significantly change the model's output, which protects against membership inference attacks. It proves that we can, in fact, accurately quantify AI security and privacy.
And finally, Section 6, the Continuous Evaluation Mandate. Let's walk step by step through the DrPinnacle end-to-end practice framework. Step 1. Define the use case, stakeholders, and success metrics. Step 2. Govern the data sourcing and quality. Step 3. Validate the model for accuracy and calibration. Step 4. Run those custom benchmarks and perform active red teaming safety checks. Step 5. Implement the strict security controls we just talked about. And Step 6, arguably the most important one, monitor and improve. This essentially guides us sequentially from the initial definition phase all the way through to secure deployment.
Picture your team staring at a high-end Enterprise Security Operations Center dashboard tracking these exact metrics. You need to track your preduments, which is a great metric combining production performance and accuracy over time. You're constantly checking your calibration or ECE, your toxicity rates, and your jailbreak success rates, making sure those stay as low as humanly possible. And crucially, you have to continuously track data and concept drift to see if the real-world data is shifting away from what your model was originally trained on.
Look, if you take literally only one thing away from this explainer, let it be this. Trustworthy AI requires continuous evaluation, not just one-time testing. Because a model that is perfectly safe on Tuesday, it might be completely susceptible to a brand new jailbreak technique discovered on Wednesday. You have to stay vigilant.
So, what does that vigilance actually look like in practice? It's a continuous evaluation and monitoring loop. Live production data feeds into the model, which generates outputs. Those outputs are immediately checked by automated evaluators, which then trigger alerts and update your dashboards. And all of this creates a constant, relentless feedback loop used to retrain and improve the model.
Now, to sustain this loop smoothly, the framework grounds us in some heavy-hitting industry standards. You'll want to align your practices with the NIST AI Risk Management Framework, the ISO 42001 AI Management System, and the OSP Top 10 for LLM applications. Plus, and this is absolutely vital, a human in the loop is a mandatory component for any high-risk decisions. Ultimately, the whole thing comes down to maintaining complete transparency, auditability, and accountability.
So I'm going to leave you with a bit of a provocative thought to consider about your own organization. Is your enterprise AI deployment truly secure and continuously monitored, or was it really just tested once? If it's just the once, well, it might be time to rethink that strategy and adopt a continuous scientific framework like DrPinnacle to ensure your AI delivers real value safely at scale. Thanks so much for joining me on this explainer, and I hope this helps you build safer, more reliable AI. Catch you next time.